Can an AI actually get a joke? I mean, not just recognize the words in a meme, but really understand the humor, the context, the whole reason it's funny? It kind of sounds like something out of science fiction, right? But it's a question that really gets to the heart of what it means for a machine to understand our world. And today, we're going to look at a new AI that comes shockingly close to answering that question with a yes.
All right, so to really see what this new AI can do, we're not going to start with some complicated chart or a bunch of code. Instead, let's kick things off with something we all get, a meme.
So here it is. You've probably seen something like it before. The text on top says, "Sometimes I just look at pictures of the Earth from space and I marvel at how beautiful it all is." And then the picture below it? It's a baking tray full of chicken nuggets, arranged to look like a map of the world. It's goofy, it's classic internet humor. A user showed this to a new kind of AI and just asked a simple question. Can you explain this? Now, an older AI would probably just say, "This is a picture of chicken nuggets." But just look at this response. It uses words like playfully suggests, lighthearted, humor, and imaginative representation. It didn't just see the nuggets. It understood the joke. It got the contrast between that majestic quote and the absolutely ridiculous image. This is a huge, huge leap forward. So the AI that pulled this off is called LLaVA. That's LLaVA, and it stands for Large Language and Vision Assistant. And that name, well, it tells you everything you need to know about why this is such a game changer. To really get why LLVA is such a big deal, we need to rewind a little and talk about a problem that's been bugging AI researchers for years, something called the vision-language gap. You see, for the longest time, AI has kind of lived in two separate worlds. On one side, you have your large language models, or LLMs. These are absolute wizards with text. They can write code, poetry, you name it. But here's the catch. They're completely blind. They have no idea what's in an image. Then, on the other side, you have vision models. These are great at identifying objects in a picture, but they're totally mute. They can tell you, that's a cat, but they can't have a conversation with you about it. The big question has always been, how do you get these two worlds to talk to each other? So, how did the LLVA researchers finally connect the eyes to the brain, so to speak? Well, it all came down to a really big idea, a whole new way of teaching these models. And that big idea is called visual instruction tuning. Now I know, that sounds super technical, but the concept is actually really simple. Instead of just training an AI to label things, dog, car, tree, you train it to follow instructions about an image. It's the difference between an AI that can only say, "That's a man on a taxi," and one that can actually answer a question like, "Hey, what's weird about this picture?" It's not just about seeing, it's about reasoning. But that leads to a massive practical problem. To teach an AI to follow millions of visual instructions, well, you need millions of examples of those instructions to begin with. Where in the world do you get all that data? Turns out, the answer involves a very, very clever trick. I mean, think about it. Creating this kind of data by hand would be impossible. It would take forever and cost a fortune. You need thousands of people just sitting there, writing detailed questions and answers for hundreds of thousands of images. So the team behind LLaVA, they had to get creative. And this is where it gets really brilliant. Their solution was to use an AI that can't see, the text-only GPT-4, to generate the data to teach another AI how to see. It's pretty wild, right? Here's how it worked. They took images that already had basic data, like descriptions of objects and where they were. They converted all that visual info into a detailed text prompt, and then they fed that text to GPT-4. Then they prompted GPT-4 to create 3 different kinds of high-quality training data from that text. First, they had it create simple, natural conversations about the image. Second, they had it generate really rich, detailed descriptions. And third, and this is the secret sauce, they had it come up with complex reasoning questions, the kind that requires step-by-step logic. This process gave them 158,000 unique examples to use as the perfect training manual for LLaVA. Okay, so the theory is clever, right? Using one AI's strengths to build up another. But did it actually work? Let's check out the results and see LLaVA in action. So here's a classic test image for AI vision. It's a photo of a guy taking part in the, let's call it, unique sport of extreme ironing on the back of a moving taxi. The question for the AI is pretty straightforward. What is unusual about this image? And the difference in the answers is just night and day.
An older model, Blip 2, gives a super literal, dry description. A man is sitting on the back of a yellow cab. I mean, it's not wrong, but it completely misses the entire point. But LLaVA, because of all that special training, it gets the context. It says that ironing clothes on a vehicle is not a typical place, and that it's unsafe and unconventional. It doesn't just see the objects, it comprehends the situation.
And this isn't just a fluke with a funny picture. This powerful reasoning really holds up in some tough, rigorous testing. On a difficult benchmark called Science QA, which requires an AI to understand diagrams and text to answer science questions, the combination of LLaVA and GPT-4 achieved a new state-of-the-art accuracy of 92.53%. So this is way more than just a party trick. This is an AI with some seriously powerful reasoning skills.
So yeah, this is a major step forward. It opens the door for AIs that can do amazing things, from describing the world for visually impaired users to analyzing complex medical scans. But, like any new technology, it's not perfect. LLaVA has some incredible power, but it also has some very real problems that still need to be worked out. A key limitation is a problem called hallucination. You know how language models can sometimes just make up facts? Well, LLaVA can sometimes make up visual details. For instance, in one test, it was looking at this picture of a fridge and was asked if there was strawberry-flavored yogurt inside. LLaVA said yes. But if you look closely, while there are strawberries and there is yogurt, there is no strawberry yogurt. It sort of mashed together two concepts it saw and created something that wasn't actually there. It shows there's still work to be done to get that really fine-grained, precise understanding right. But even with those limitations, the progress here is absolutely incredible. We are moving so fast towards AI that doesn't just process a bunch of pixels, but truly perceives and understands the visual world in a way that feels, well, conversational and maybe even a little bit human. Which leaves us with one big final question to think about. As AI really learns to see our world, what are we going to ask it to look at next?